Hi, my name is Yarita Garcia, and today we're gonna go over the practice test. I'm gonna go over each of the questions. I'm just gonna tell you how I did it, and let's start. Okay, we're gonna start here. Okay, we're gonna start with the first question. Basically, in the first question, it's asking which of the following are functions. So here, what I did was the first thing that I did was to look at the first number, that is the domain, and the range. So whenever the domain have the same number, that means that it is not a function. So I went to look which number was the same, and the only one that it had the same numbers was letter C. So that one was the first one that I scratched it out. On letter over here on F, basically I cancel it out. They have the different domain, but the thing is that it doesn't have like the parentheses. It's only have brackets, so it doesn't look like a function. Here, the first one, it does have the brackets, it doesn't have the parentheses, and usually it doesn't have repeated the domain. It have the same range, but basically the same range. It doesn't matter if you have the same range, it's still a function. The only thing you need to look first is that they don't have the same domain. So that's I check each of them, and for me, the ones that looked like a function, it was A, B, D, and E. So we move to the second question, and the second question said let f and g be the function given by f equals brackets parenthesis 2 7 4 6 5 8 6 5 7 8, and g equals 2 9 3 4 4 9 5 2. So on letter A, it says find the elements that belongs to the domain of G but does not belong to the domain of F. So what I did here, I just put here the domain of G equals 2, 3, 4, 5, and the domain of the F equals 2, 4, 5, 6, and 7. And then I just, let's say, just scratch it out, and I just check how much it will be, how much belongs to the G but doesn't belong to the domain F, and I came out with 3. Okay, continuing to the B, it's a simplified f of 5 minus g of 2. So in here, what I did was that I went to and look f of 5. So I went over here, f, and I looked for the domain that is the 5, and it was the number 8. So I put here f of 5 equals 8, and I went to g of 2. So I went over here, g of 2 equals 9. So then I just did 8 minus 9 equals -1. So my answer was -1 for this one. For the next one, for the C, it said solve the equation f of x minus 2 equals 8. What I did here is I just did x minus 2 first. So here I went to look which two numbers, or which number has 8 as a range, so of f. So I went over here and I looked at the 5 and the 7 have the 8 as a range. So what I did here is put the 5 and 7. So here I just did a little calculation. I put here plus 2 plus 2. If I were to use the 5, plus 2 equals 7. And I did the same here. And I did the same thing over here. And I put here that the x equals a 5 or the 7. For the next one, it's let q equals hk and r equals msu. Find the power set. So what I did here, they want the power set of q. So what I did here is just just use the power set, the function of q. So the power set could be an empty space. It could be letter H by itself, letter K by itself, or H and K. They're the only ones that could be the power set of Q. Here they want to find R times the Q. So here we're gonna combine both. So what I did here, it start with the R because it's showing that you need to start with the R. So I just put M. I just start with the M here. So I start with the M and then I put MH, MK, and then I start with the S, SH, SK, and then with the U, UH, UK. And over here for the C is showing if Q included the additional J, then how many more elements will the power set have? So what I did is I put that Q equals the H, the K, and the J. So I did the power set like I did here. I put the empty space, the H, the K, the J. Now I include the J, the H, the K, HJ, and KJ. And there were 3 more than we have over here. Okay, next question number 4. Here show if H is a function of T, it is an element of the domain of H. Then H of T is, for this one I put B, the order pairs belongs to H with the second coordinate of T. So since we're using the H, the function of H, so that's when I put that the order pair belongs to the H. And since T is an element of the domain of H, so it's the second coordinate. It could be like the range. Number 5. It says let F be a function consisting of exactly 50 order pairs. How many elements belong to the range of F? So here what I did, well, this one, I just figured out that, okay, if F be a function of exactly 50 order pairs. So if we have 50 order pairs, we need to have, we're going to have 50 domain. We're going to have 50 domain and 50 range. Because if each of order pair have a domain and have a range. So if we want 50 order pairs, we're going to, of range, we're going to have exactly 50. On this one, it says let H equals A, B, C, D, K equals X, Y, and Z. Give an example of the function F from H to K whose range does not equal its codomain. So on this one, basically, I didn't use all of K because it here is showing that the range do not equal to the codomain. So here what I did is F equals, I use the AX, the BZ, the CX, and DZ. So I didn't use any of the K elements. Well, I use 2 of them, but I don't use the 3 of them. And I use all the H elements here. For number 7, this one, it says let H and K be defined as above. Then how many functions are there in H times H to K? So here what I did was basically this one I usually it helped me a lot when seeing the videos. So what I did here, it's similar what the teacher did, was that here I put like A, B, C, and D for 4 times. And then over here, since it's 4 here, 1, 2, 3, 4, so I put 4 times A, B, C, and D. Then after that, what I did, it just like show like here A, B, 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 C, B, D, B. Like I used the same 4 of them here, like A, B, 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 and B, C, 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 and C, D, 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 and D. And then I count them all in total. And what I did was 16. And here are just 3 elements. So what I did here is 16 to the power of third. And I did the calculations. and it was 4,086. On this one, number 8, it should let C be a set of coordinated 8 and let D be the set of coordinated 6. Which of the following is false? So this one, it's the one that I think is false. There's a function from D to C whose range equals its codomain. There's a function from C to D whose range do not equal the codomain. That is true because the 8 doesn't equals to the C has 1, 2, 3, 4, 5, 6, 7, 8. The D it has 1, 2, 3, 4, 5, and 6. It's into 6. So here it's true because it doesn't have the range. It doesn't equals to the codomain. So there's one that doesn't equal. This one is the same thing. If you go either of the way, it does not equal to the codomain. And there's some that they from C to D they do equal, but from D to C they don't because C has 2 more. That's why I should be that it's a false. Number 9, I was kind of confused with this one. But number 9, what I did, it says let number equals 1, 1, 1, 2, 2, and 2. The number sign is not a binary operation of 1 and 2 because what I did here is basically I did a chart from the I got it from the notes. It's similar to the notes, the binary operation notes. So what I did here was that I like did the chart like 1 2 1 2 1 equals 1. So after I did that, I find out that the domain of the number sign is not 1 2 times 1 2. It's only 1 2 in all. So that's this one is not a binary operation. This one it does because it's here, but this one it doesn't. So basically that's how I did. I just figured out like the chart we use for the binary operation notes, and I found out that the domain of number sign is not 1 2 times 1 2. So going to number 10, this one it was kind of confusing. So suppose that I believe that it's a sign. It's a binary operation of the set S, and that D, Q, and U are elements of S. Write the equation that is more common way to expressing that numbers money sign UK equals D. So what I did here is I just become with this equation because usually it's saying that S and that DQ, DK, and U are elements of S. So I put here S first and then equals these elements. Then after that, what I did is suppose that money sign is a binary operation of S. So that's what I put the number sign here in the middle. So it shows that S money sign equals the elements of D, Q, K. Okay, the elements of S money sign equals D, K, and U. That's how I become with the equation. On the next one, number 11, it says how many binary operations are there on a set of cardinality 10. So what I did here, I went from 1 to 10, and then after that I shows that 10 to the n power. Since we're doing the cardinality 10, I figured out it was 10 to the 10th power. On the next one, on number 12, it says consider the binary operation pound on 2, 3, 5, 6, 8, and 9. So on A, it shows simplify 8 pound 6 squared pound 9. So what I did here is basically I first figured out the 6 to the second. So what I did here is put 6 pound 6. So I figured out that it was 3. 6 pound 6, it was 3. So here what I did, it was put 8 pound 3, because 3 was a 6 squared, pound 9. So here first I did the parentheses, what inside the parentheses, 8 pound 3, I did 8 pound 3, it was 2. And then after that, pound 9. So I checked 2 pound 9, it was 6. So that's how I become with the 6. The next one is solve for the equation x pound 9 equals 3. What I did here is I went like I did x equals 8. How I found it was 8. It was here, what I did was 8 pound 9, it was 3. So I went and look, because I know that something pound 9 was gonna be 3. So I was 6 and 8. But the only one that it was that fixed was the 8. Because here when it's x pound 9 equals 3, so automatically, okay, I was like, okay, so it's pound 9 equals 3. I need to go pound 9, something that equals 3 is in between 6 and 8. But I find out that it was 8. X, it was 8. Over here it says consider the binary operation pawn on the irrationals, the set of the rational numbers defined by. So here it says simplify 0.7 pound negative 2.8. So here I just did if it was h and the k. So here I put here showing that h pound k equals 3h minus 2k. So here what I did, it was I put the 3 that it's over here, and from the h I put the 0.7 minus 2 that is over here, and for the letter k I put the negative 2.8. I simplified them and it was 7.7. Over here it says solve the equation for 8 pound x equals 5. What I did here is 8 pound x equals 5. So here what I did, it was I put here that 3 times the h, because it was like h and k. The 3 times the 8 minus the 2k equals 5. And then here I did 8 times 3 equals 24 minus 2k equals 5. And then over here minus 24 minus 24 here equals 19. 19 divided by 2 equals 9.5. So this is the answer. It could be 19 over 2 or 9.5. Over here, letter C, it's simplified 8 pound B pound C. So what I did here is I first started with the parenthesis, what is inside the parenthesis, and I replaced them like an H and the K. So here I put 8 pound B and C, 8 pound 3B, because I replaced them with the H and the K. So it was 3B minus 2C, and then I simplified them, and I got 3AB minus 2AC. On number 14, consider the following statements. Addition is a binary operation on the set of even integers. Multiplication is a binary operation on the set of even integers. If we do an operation of integers in addition or multiplication, these two statements for me, they are true. Because on prime numbers, on prime integers, addition it's not. So I just figured out that if in prime numbers, on prime integers, addition was not, and multiplication it was also. So I was like, okay, so if a prime integers was not addition, on the even integers it should be like it should work on addition. So basically for me, both of 1 and 2 are true. Going to the next one here on the number 15, which of the following illustrate why exponential is not a binary operation on rational numbers positive? So basically I went over each of these ones. What I did was like I did like 1/2 to the power set of 8. So I found the answer and it was a rational number. So here I did the same thing, 1/2 to the exponential of 9, and it was a rational number. Here, it was a to the power of 1/2. It was a rational number. And D, when I did 9 to the power of 1/2, it was not a rational number. So that's why I chose D, because this one is the only one that show it's not a binary operation of the rational numbers. It gave me like a whole number, like a real number. So here it says let f be the set of functions of reals to real, which the following defines elements of f to the f. So on this one, what I did basically was like input some numbers. So I put like 1, I put like 2, 3 for x. So the only one that it was giving me a whole number, not a rational number, was in letter A. So when I did like the calculations, like here, it would put like 1, and this is 1. 1 minus 1 is 0. This is gonna be 1. That is not a rational number. It's a real number, a whole number. So that's why I choose A. For this one, let C and D be the functions to real defined by. So here it shows that C of x equals 4x plus 5, and D of x equals x to the second power plus 6. So here it says simplify D to C, or DOC, and times the 3.1. So what I did here is just replace them with a G and with the F. So usually this one, it was an example from the notes, not this actual equation, but it was a similar. So what I did, I just I went over the notes and I just replaced them like with the F one with the G, and then I put D, and then C of x inside equals the D. So C of x equals the 4x plus 5. So I put it in here, equals 4x plus 5 squared plus 6 times the negative 3.1, because this one I simplify them in both and it becomes with this. So I got negative 12.4x minus 96.1. That's what I got for this problem. On this one, which of the following is not a binary operation? What I did here was that I went over, I looked at here. Here is the money sign, 1, 2, 3, 1, 2, 3. So this one, it was 1, 2, 3, 4, 5, 6. There was 4, 5, 6, 4, 5, 6. 1, 2, 3, 1, 2, 3. So whenever it's a binary operation, it needs to have 1, 2, 3, 1, 2, 3. It can't be 1, 2, 3, 4, 5, 6. It can't be different numbers. It needs to be the same numbers. Since B was the only one that have different numbers, that's why I chose B, that it was not a binary operation. Okay, so number 18 was the last question. That's how I did the exam, the practice test. I hope I got most of them right. Probably some of them may not be right, but I try my best. I usually go over the videos and the notes, and the exercise helped me also. And based off that, I did this test. So thank you, and bye-bye.